This video is on simplifying radicals from a pre-calculus assignment in Chapter 6. First problem that we're going to look at is the square root of 8 over 16, and I'm going to simplify that by first looking at the square root of 8 and breaking that into 4 times 2 divided by 16, and then the square root of 4 is 2. So the numerator becomes 2 square root 2, and the denominator 16 can be written as 2 times 8. And those 2's will cancel, so the most simplified form of the answer is square root of 2 over 8. That's not necessarily the only way to do the problem, but I think that's the best way to do this one. Then 1g, you have two choices I think are reasonable. You can take the square root of 6, and even though the factors of 6 are not square numbers, it doesn't really matter because there's a square root of 2 on the bottom, and so the square root of 2 that is in 6 can cancel with the square root of 2 that is on in the denominator. So one way to get to the answer is that way. Now that might not have been the first way you thought of, so perhaps you took this question square root of 6 over the square root of 2 and decided to rationalize it by multiplying top and bottom by the square root of 2. That would be fine. You can do that, and the numerator would end up being the square root of 12, and the denominator would end up being the square root of 4, and the square root of 12 is 4 times 3 over the square root of 4, which is just 2. So the square root of 4 on the top becomes 2 root 3, and the square root of 4 on the bottom is just 2. And the 2's cancel, leaving the square root of 3. So same result, different method, and those are not the only two ways of getting to the square root of 3, but two good samples. Alright, so next problem 2D from the worksheet. We have to take the 3 and break each of these radicals up into their simple radical form to see if they can combine with anything. So I'm going to use 4 and 7. Now 88 could be 8 times 11 or 4 times 22, I think would be better. And then 2 and 112 probably has 4 in it. It's at least 4 times, what, 25, 26, 27, 28. 4 times 28, which means it's 4 times 4 times 7, or 16 times 7. So now that we see that, let's move on here. So the 3 can stay. The square root of 4 is 2. And the 7 is here. When you take the square root of 4, it multiplies this 3, because remember, since there's no symbol here, it's a multiply. The absence of a symbol in math means multiplication. So when the square root of 4 comes out, the 2 multiplies the 3. Then here we have 4 times 22, and the square root of 4 is 2, and the 22 stays trapped. And then here, if you wrote this as a 16, then just a 4 comes out. The way I've done this, the square root of 4 is 2, the square root of this 4 is 2, and the square root of 7 is trapped. So we have 6 square root of 7 plus 2 square root 22 minus 2 times 2 times 2 is 8 square root of 7. So the 6 square roots of 7 subtract 8 square roots of 7 gives me negative 2 square root of 7. And the 2 root 22 does not combine. It is not a like term. with the other. So I'm going to go ahead and write the positive one first and subtract the 2 root 7. It would be fine to write that as negative 2 root 7 plus 2 root 22. Okay, either one of those is fine. All right, next here, I hope that you can see the structure in this problem is the same as a binomial. Two binomials multiplying each other. So for example, the method that you would use to multiply this is the same as the method that you would use to multiply something like x plus 4 times x minus, oops, I wanted a 4 there. Doesn't really matter, but I said 4. So x plus 4 times x minus 5. So you could FOIL it, or you could use the distributive property twice. Depends on maybe the wording that your teacher might have used in Algebra 1 when you learned how to multiply two binomials. So I'm going to do this. I think I'm going to lay out the distributive property twice. So we're going to take the 2 root 3 here and multiply it by the 3 root 6 minus 5. That's this part. And then we're going to take the 4, the plus 4 here, and multiply that by the 3 root 6 minus 5. Okay? So then 2 root 3 times 3 root 6, the 2 and the 3 multiply to give you 6, and then the 3 and the 6 multiply to give you 18. Then 2 root 3 times 5 is 10 root 3, and 4 times 3 root 6 is 12 root 6, and 4 times negative 5 is negative 20. So the 6 root 18 needs to be simplified because 18 has the square factor of 9. And 10 root 3, 12 root 6, oops. It's a mess. 12 root 6 minus 20, and so the square root of 9 is 3, and 6 times 3 is 18, square root of 2 minus 10 square root of 3 plus 12 square root of 6 minus 20. Okay, now nothing here combines because none of these terms are like terms with any of the others. The radicand part has to match or you cannot combine like terms. Alright, next for C we have a fraction and we want to rewrite this as a single fraction. So there's probably more than one way to do this problem as well, but we also don't really want a square root in the denominator. So first thing, I'm going to fix this 1 over root 3 and change it to simple radical form by rationalizing the denominator. I'm just going to squeeze in a little root 3, and hope you're okay with the numerator of the first fraction becoming root 3, and then root 3 times root 3 is root 9, or just 3. So now we have the fraction root 3 over 3 plus root 3 over 2. So it's just two fractions, they need a common denominator. Multiply this one, top and bottom, by 2. And this one, top and bottom, by 3 to create a two new fractions whose denominator is 6. So that's 6 on the bottom and 2 root 3 on the top, and 6 on the bottom and 3 root 3 on the top. And so altogether, when you add that up, you get 5 root 3 over 6. All right, and the last one for I, I'm going to do this multiplication first here. So this becomes 3 root 3 over 2. And we can make this 3 over 1 to see that. 3 times root 3 is 3 root 3, and 1 times 2 is 2. And then 6 times root 3 is just 6 root 3. We can put that over 1. And again, we need common denominators. So I'm going to take this fraction and multiply top and bottom by 2. And then we'll get 3 root 3 over 2 plus 12 root 3 over 2, and a total of 15 root 3 over 2. So that was a sample of 6 problems from the Simplifying Radicals assignment for pre-calculus, and I hope that was helpful. You can always come by to get more help, but hopefully by watching those you can get most of your questions answered on any of the other problems.